This is the first video in a series of videos on gases. It is meant to provide an overview of some of the key concepts that we'll be trying to cover, as well as identifying the different terms that you'll need to know by the end of the series of videos on gases. So the first thing is the reading that you'll find in your textbook, the Trow 2nd edition, is chapter 10, 10.1 through 10.7. We're going to skip 10.8 and 10.9, and then pick back up for 10.10 and 10.11. In terms of the learning objectives, these are the ideas or things that you should be able to do by the end of the series of videos. So given three of the following for an ideal gas, determine the fourth: pressure, temperature, number of moles, and volume. So what you'll see on an exam is I would give you three of them, so maybe pressure, temperature, and number of moles, and ask for volume, or give you volume, temperature, and pressure and ask for the number of moles. Another objective would be to be given a change in one of the main components for gases and determine the change in another. So given a change in pressure, determine the change in temperature. Given a change in temperature, determine the change in volume, and so forth. Determine what we believe is going on at the atomic level for Boyle's law, Charles' law, Avogadro's law, and Gay-Lussac's law, as well as being able to describe what each of those laws is. Given the concentration in a mixture, determine the partial pressures and total pressures for a gas. Given three of the following, and using the van der Waals equation, determine the fourth under high pressure conditions: pressure, temperature, number of moles, and volume. So some of the key terms that will be discussed in this series of lectures are Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, partial pressure, van der Waals, standard temperature and pressure, the definition of that, and how that differs from standard ambient temperature and pressure. Molar volumes, pascals, partial pressures, and mole fraction. So why are we so interested in gases? Well, the weather is an example of the interaction of various gases in our atmosphere. So variations in the Earth's atmospheric pressure create wind, and changes in pressure enable us to predict the weather. So if you're ever watching the news and you see a map similar to the one that we have down below here, where you have a series of H's, L's, and then dashed lines, what the H is meant to signify is a region of high pressure. This is usually associated with clear wind. The reason for it is high pressure tends to sit in one place and not lift vertically. L on one of these maps is an indication of low pressure. Now, low pressure systems are ones where you have an instability of weather. Because the pressure is low, you would have air from above sinking down into it, and that creates high winds and a lot of instability in the weather. Now, the number of gas particles in a given volume decreases with increasing altitude. So as you go up, the pressure is going to decrease as you go up, which is one of the reasons why they need to pressurize cabins in airplanes. If you normally flew at that altitude, you would actually not have enough air to be able to breathe in. Another example of gases and pressure is your ear. So if there is a difference in the pressure across the eardrum membrane, the membrane itself can either push in or push out. When it pushes out, this is what we commonly call a popped eardrum. You can normalize the pressure by either chewing on some gum, which ends up moving your jaw, which opens up this little area here, allowing gas at the same pressure as outside your ear to go up and regulate the pressure so that it equalizes the pressure between the inner part of your eardrum and your ear canal. Or you could plug your nose below, and that would also force air to come up here and establish an equal pressure between the inner and outer part of your ear.